All right, Riemann sums. So R-I-E-M-A, and I believe there's two N's there. All right, so all that a Riemann sum is or does is it approximates an area beneath a curve. So, and we call them, maybe we'll just say area under a function. Usually you see curve. Curve we just kind of use as the general term for a function or on a graph. So let's take a look at what we're going to do first, and then we'll go through a real easy kind of example just to give us a look at one of these in action. So what we're going to do, because we're talking about areas, we're going to have some function. So let's use our sigma notation. So we're going to add up these different areas from some value, k to n, of f of x sub k times the change of x. So all that this is, if you think about it, like over here, you're going to have some delta x right here. So this is how much it's changing to the right and to the left. You could think of it like the base. And then you're going to have some function f of x up here. So that's going to give us the height. So really all that we're doing when, this looks a little more complicated than it actually is in real life. All that we're doing is we're taking rectangles. So we're going to add up different rectangles as they fit beneath a curve, and then, well, I guess not beneath, sometimes they go above depending on what the curve looks like and stuff like that, but we're going to approximate the area under the curve using these different rectangles. So if you look at the book, we'll go through an example with a left, right, and a midpoint. Personally, when I do these on my own, I don't really look at sometimes math notation can be it's good in that it's very specific, but it can also be a little bit confusing if you're just kind of getting used to it. So let's go through a quick example, and I'll just show you how I do them, and hopefully it'll sort of clear things up just a little bit. So let's take a function, maybe like an easy, like f of x equals x squared, and we'll figure out, we're going to approximate the area under that curve. We'll give ourselves 0, let's go to 3. All right, so we give ourselves the domain, and then we're going to approximate it, and we have 3 different ways to do it. You can either do a left, a right, or a mid. So we'll look at those 2 differences. So let's see, I'm going to need 2, 4, 6, 8, 10, and then 1, 2, 3. All right, so we'll do this is every 2 on this one. So 2, 4, 6, 8. All right, and then 1, 2, and 3. Okay, so let's sketch our curve or our graph real fast. 1 squared is just 1. 2 squared is 4. And 3 squared is 9. So we connect these and try to smooth. Oops, that's not really going to be smooth, but there we go. All right. Yeah, sorry. That one didn't come out good. But this will give us the idea. Okay, so when we're talking about a left, a right, or a mid, let's do the left first. So all that this means when you're taking a left Riemann sum is that you're going to take all the values as they go to the left of your delta x. So we'll set, let's say, well, let's make this easy. Let's say delta x equals 1. All right, so the base of our rectangle is always going to be 1, and the left, right, or midpoint is going to tell us what the height's going to be. So here's our first block right here, is from 0 to 1. All right, and the left midpoint means that our first one is going to be 0. Okay, so that area is 0, so that's pretty easy. All right, so now this one, so here's our second block from 1 to 2. And the left, at the very left of this, is going to be the value of 1. So that's going to give us the base is 1 and the height is 1. So that's 1. All right, and then this last one. So now we have the block from 2 to 3. And at the left of the block, so the left of this is going to be 2 squared. So 2 squared, that's going to be 4. So our height is 4. And our height is 4 and our base is 1. So 4 times 1, that's just 4. So if we take the Riemann sum to the left, this is going to be 1, 0 plus 1 plus 4. So that's going to give us 5. Okay? Well, let's, I'm going to try and squeeze it in over here. Let's do it to the right. And we can show the difference. 1, 2, 3. All right. 2, 4, 6, 8. Okay, let's draw our curve again. 1, 4, 9. Hopefully I can draw this one a little bit better. Nope, not much better. Okay, so that was to the left is that one. So this one's going to be to the right. All right, so now our delta x is still the same. The change in x is still the same. But now instead of taking it from the left, like we took 0, 1, and 4, now we're going to take it to the right. So for our first chunk right here, we're going to have our delta x is going to be 0, but our height, because we're taking it right here, is going to be 1. So this is going to be 1 times 1. That's just 1. All right, now the second chunk, we're going to take the right end point, or the right point, so that's going to be 2. So this one's going to have a height of 4 and a base of 1. So that'll be 4. And lastly, we're going to have a height of 9, because remember we're on the right hand side of this, so a height of 9, and the base is going to be 1 again. All right, so this is going to be 9. So 1 plus 4 plus 9, that's 9, 10, 14. All right, and so 14 is going to be this approximate. You notice the difference here between the right and the left, and we have a pretty big spacing for our delta x, but you notice these are mostly above the curve right here. So this is probably going to be an over approximation, where these ones are all below the curve. So this is probably going to be an under approximation. So that's the left and the right. Now let's take a look at the midpoint. So 2, 4, 6, 8, 10. 1, 2, 3. All right, so let's draw our curve. 1, 4, and 9. All right, there we go. Let's scroll down just a little. All right, so our delta x, let's get rid of that. There we go. So this is going to be the midpoint. So when we're talking about midpoints, that's just like it says, we're going to have to find, the height is going to be whatever it is right in the middle here. So that's not too hard for us to do, because we have this function. Remember, f of x equals x squared. So let's take out our calculator. Our base is going to be 1, but let's figure out what the height is for this first one. Okay, so we've got The midpoint between 0 and 1 is 1/2, so that's 0.5 squared, because that's our function. So this is 0.0 or 0.25. So we have 0.25 times 1, which is 0.25. Remember, don't forget to multiply it by the base. That's kind of the trick. Don't forget that. All right, so now this one we're going to have. So this is 0.5. This one's going to be 1.5. So we have 1.5 squared. So that's 2.25. And again, just to reiterate, you're going to these are multiplied by 1 because that's our change in x. If your delta x was like 0.5 or whatever, if you want to make it smaller or bigger, you have to make sure that you're multiplying this by the area or by the base, or that delta x. Okay, then the last one, we had 1.5. Now we'll have 2.5 squared. So the height of this one is going to be 6.25. And 6.25 times 1, that gives us an area of 6.25. So we've got 6.25 plus 2.25 plus 0.25, and this equals 8.75. And I would say, just again, you kind of look at the graphs to see if it over or underestimates. And this one looks pretty good between these two. You see it's between them. It's between 5 and 14. And also you'll notice that half of it's, not half because it's an exponential function, but it's maybe not an exponential function because it has an exponent. So, it's not going to be like a 50-50, but you'll see it's probably a little bit better estimation because you have some over and some under. That makes sense that it'd be between those two. So that's how you look at over or underestimate. You just look at the graph, or you can even, you don't have to draw it out. You can kind of think about it logically to see. But that's the basis. That's the idea of Riemann sums. And as you'll see in the next chapter, this forms kind of our understanding of integration and why integration gives us the area underneath these curves. So hopefully that's enough to get you going. And if you have any questions, just let me know.